The name Tite Bond is well known in the woodworking community for their wood glues, but did you know that they have other impressive product lines? Tite Bond's construction adhesives and caulks and sealants are made with a professional in mind. Builders and contractors depend on Tite Bond to deliver the most consistent and high-performing construction adhesives for their projects, including the industry's #1 FRP adhesive. Tite Bond's line of caulks and sealants ensure unbeatable adhesion for a wide variety of applications and weather conditions, with the most comprehensive color matching program in the industry. To see Tite Bond's complete variety of products, visit their website at titebond.com.
Typically, I think if a homeowner is getting ready to spend more than, say, a couple grand, they should probably get an energy audit because it has a huge impact on not just energy use, but building durability. And so it benefits not just the individual, but the entire community.
Welcome to the Fine Homebuilding Podcast, our weekly discussion of building, remodeling, and design topics aimed at anybody who cares deeply about the craft of and science of working on houses. I'm Senior Editor Patrick McComb. Today I'm joined by Fine Homebuilding Senior Editor Brian Pontalillo.
Hey, everybody.
Our producer, Andres Samaniego.
Hello.
And our special guest, building science, Monica Rokicki. Please email your questions to FHB Podcast at finehomebuilding.com. You can find previous podcasts and check out the show notes at finehomebuilding.com/podcast. Monica, it's a pleasure to have you on the show. Thank you so much for being here.
Oh, I'm so pleased to be here with you all and discussing some thorny questions in building science.
You said it, because that's what we do. We were introduced because you're currently or recently finished producing an e-learning module for Fine Homebuilding. Before we get to talking about that, which we will shortly, can you please tell me what you do for a living and a little bit of your background by means of an introduction?
Sure. So my background started in architecture, and I was a leader of a design team at a local mid-sized A&E firm and fell into building science when I first saw an energy audit. And the power of that was so, illuminating. You know, you could actually use science to know whether a building was working right or not, and also to design it properly to begin with. And so I ended up starting my own company, Better Building Works, in 2011. After having taken some courses around like ResNet and HERS certifications and BPI certifications, et cetera. So it's a wonderful rabbit hole.
Monica, when you told me about your background when we first chatted, you kind of explained that you were headed towards this at your first job as an architect at that firm. You were headed towards it, and I think like you kind of had. It sounded to me like you had identified that it was a missing component in a big architecture firm.
Absolutely. And so I approached the firm. Now, of course, this is 2011. It's, the recession. And I approached them to at least start doing, for example, energy audits on these homes that we were doing large renovations for. And they were kind of the mind, what we're doing isn't broken, so we don't need to fix it. But my concern with the way that the building would operate, as well as all of the missed opportunities for whether it was scope definition for the project or indoor air quality or controlling energy costs in the future, making the house more comfortable, it just seemed to me that that was something the industry needed. And that's why I started the company.
And do you think do you feel like it's kind of I ask this because now we have an expert on, and I'm always sort of like touting the benefits and the reasons to have an energy audit done. So now we can have some facts on the show. But do you think is in older houses, do you feel like an energy audit should kind of be like just standard par for the course on remodels? Are there cases where it's not necessary before a significant remodel?
Typically, I think if a homeowner is getting ready to spend more than, say, a couple grand, they should probably get an energy audit. And, of course, not all energy audits are created equal. There are bad ones. There are ones that aren't even energy audits. I mean, there is a legal definition for it. But one proposal that I made to the city that I'm in, Roanoke, Virginia, is that they require energy audits or at least give some really great incentives for homes to get energy audits, because it has a huge impact
Hmm.
on not just energy use, but building durability. And when you think about it from, for example, a municipal level, um, imagine how it preserves that very valuable building stock across an entire city or town.
Yeah.
And so it benefits not just the individual, but the entire community.
Yeah, and we had a pretty a story in our magazine recently that was it was about air sealing and insulating a roof on an old house, and it was, I mean, it was essentially, even though it was a focused article on the roof, it was essentially part of a pretty deep energy retrofit, which in energy retrofits get debated a lot in terms of their, you know, either payback or ROI, or however you are looking at it, the cost effectiveness of them. But the author said that, like, you know, this is the sweet spot. These people wanted to remodel their house for aesthetic reasons, for
Yeah.
livability, and it just needed updating. And, you know, he said, so we do the energy audit because when you're going to do that much work, all of a sudden the performance upgrades become cost effective.
Oh, absolutely. We did, for example, we do design work as well still. And so we did a design for a 1,500 square foot addition on a 1940 home in, right around here in Roanoke. And their energy bills, because we incorporated the energy audit and informed decisions through the design process, their energy bills are the same now with a 1,500 square foot addition. So
Yeah.
I mean, it paid for itself like in 3 months, the energy audit
Yeah.
or less, and the appraisal value tied into a lot of other things.
Yeah.
So,
And you say, Patrick, I'm sorry, I just have a bunch of questions. I know you have some too. But Monica, you say in your article, that your forthcoming article that hasn't been published yet, that you've actually seen houses where they've done performance upgrades and their energy bills have gone up because they didn't do the
yeah.
energy audit. So what's that all about?
Oh, it makes me so sad. Yeah. I mean, sometimes, individual product and service organizations are trying to sell their products and their services. And sometimes homeowners can be led to make purchases like windows or certain kinds of insulation upgrades without understanding the feedback loops that are happening in the building. And so if you get a building that is super leaky, sort of like at the top and the bottom, and then you replace the windows, what you've done is you've made a better chimney. And so in the winter, those bills can actually shoot up because they're literally losing more energy through the top of the building than before they replaced the windows.
That's really fascinating.
Yeah.
That's why it's building science.
Yeah.
we were
Yeah.
just
Second
yeah, we
law.
were just talking about this term yesterday and why we keep hearing it more and more and more. There's the answer.
Yeah.
So, Monica, what's the Fine Homebuilding course about? I mean, your interests and skills are broad. How did you focus the course, and what is it focused on?
Indoor air quality is such an interesting topic, and I was very interested in it, of course, prior to the pandemic, but the pandemic really brought it forward in terms of how important it is for controlling whether it's infectious diseases or even keeping mentally alert while we are at home working, etc. So I got really interested in the work of Dr. Richard Corsi during that time, and many other building scientists around the country, and Dr. Miller. There's so many, but indoor air quality and building safety are central to any kind of work that is done in a building, whether that work is a design or, I'm going to add an addition or I'm going to build a new home. Building codes are really the whole reason for a building code is health and safety, right? So we've got to put indoor air quality first. And I was starting to see out there, a lot of energy efficiency upgrades that did not take into account air quality. And you were talking earlier about Brian, about how energy bills can go up if you do the wrong thing. Well, indoor air quality problems are unfortunately probably a third of our business, because we're called in to do diagnostics sometimes when homeowners do work that they think is going to be right without understanding the science, or they implement something that's been sold to them without understanding the science, and now they have moisture issues or biological growth or comfort situations. So dust is a big one, believe it or not. I mean, but dust is stuff that gets in our lungs, right? So that's air quality. All of these things that I've talked about are air quality. So it all relates. It all comes right back to how can we be happy and healthy and prosperous in our buildings.
So what will folks learn if they take that course? And you all are going to want to stay tuned because we're going to have a discount for it at some point during the show to get folks to go there.
Well, what I hope people take away is that, first of all, a building has lifespan, and that lifespan almost always exceeds, the duration of someone's occupying that particular building. So in a way, we are stewards for that building while we own it, or even while we occupy it. Um, and so from the course, I hope that whether it's at the point of new construction or renovations, or maybe even just minor upgrades to an existing home, or in figuring out what the heck is going on if there's a problem, the ways that building science with an indoor air quality centered approach can solve multiple problems at once in the most cost effective and resource effective way possible.
Why do you think indoor air quality has been low on the list of building science priorities for most folks?
I mean, I think it's one of those invisible things, right? So it's like people just, I mean, air is not visible. And so we don't think of it as there's anything going on in it, right? So we can look at the ocean and see a bunch of fish and algae and things like that in there, right? We can look at corals, we can look at this sea life, right? In water. But in air, there's all kinds of life as well. It's just really, really small. And that life, we're literally breathing and exhaling and inhaling inside of a microbiome inside of our homes. And that is a lot of it affected by the way air, moisture, and heat will move inside of that building and interact with surfaces or different kinds of like stove emissions or furniture that you bring in. So learning about that and how the building science principles inform it, it's kind of tricky for people to get their heads around it. But when they understand that it's going to make them happier, healthier, more lively, CO2 levels that are going above 800 parts per million have effects on us. And, we can get kind of bored. We can get, lethargic. And that's the last thing we want to be when we're trying to learn something in school or, caring for children or working at our desk.
That's our problem, Brian. That's what's going on.
I know. Well, yeah, isn't it fascinating, right? I don't think there's anyone there's probably not a human, who hasn't had that experience of like just waking up a little groggy or a little fuzzy in the morning. And like, there could be other causes of that for sure, but there's also a good chance that the carbon dioxide levels in your room where you're sleeping that night just were high. And imagine the people that work at home now and like you were just sitting in rooms breathing. We're creating the problem. It's circling right back into our bodies. And we just need often maybe just a little ventilation.
Well, yeah. But then, how do you do the ventilation right? I mean, in 10,000 years, we've been building buildings a certain way. And then we suddenly have like the ability to control heating and cooling with air conditioning systems that we just start putting willy-nilly in different places and thinking it's all going to work. Well, the game has changed now, and we've got to be much more intentional and, fact-based, science-based about the decisions we're making. And if we can do that, that's a huge opportunity. And it literally sets a baseline for how healthy we can be. Like your building that's the limit, right? No matter what you do, you're going to bump against those literal walls in terms of your well-being if you don't do it right.
Well, I think, you can't say just add a little ventilation to Monica Rokicki because she's gonna tell you that it's not that simple, and that's why you have to take this course because it's 6 hours of. This is not a course that scratches the surface. This is a course that plumbs the depths.
Monica,
So
is this stuff easy to solve in many cases, or is it always a heavy lift?
I don't think it's a heavy lift for, a building scientist who understands how these systems work. But the key is a building scientist is a kind of a bridge between silos. So we typically think of a house as made up of all these separate parts, right? There's the insulation parts, and then there's the system parts, and then there's the framing parts. And, so you call a different person to do all of those things. But where building science comes in is in the interactions. And in my opinion, we need lots and lots more building scientists. We do have, a growing field. It's really coming out of low income weatherization, married to, I would say, like more like commercial level engineering that's always been around. But it's kind of that missing middle
mm,
almost, right? That market rate residential application of building science that holds so much promise for the health of our neighbors as well as the well-being of our buildings.
Well, I got a couple questions for you in a little bit, but let's get to some of our listener feedback. So that's probably you probably know that's part of the show, Monica, if you've listened to it. And
Mhm.
if you haven't listened to it, that might explain why you're on here with us. But thank you anyway for being here. It's a pleasure to have you. Our first feedback email comes from Aaron. Hey, FHB Podcast crew, back in August last year, I caught up with the current FHB podcast, so I started going through the back catalog. I was listening to episode 5 where Brian said an outdoor shower changed his life, while coincidentally, I was building an outdoor shower. I just got around to publishing a video post about building it. Hope he's okay that I quoted him in the video. Here's a link. Did you see this, Brian?
yeah, I did. And this was such a nice, fun letter to get for so many reasons. For one thing, it brought me back to the days of episode 5 in that article that I did on building an outdoor shower, and the debate about whether the headline for the article could be "Change Your Life with an Outdoor Shower." But it's true, right? It's true that it's often we have to, we're talking about indoor air quality and heating and cooling equipment and all these big things with important things with serious implications on the podcast all the time. But it's also true that sometimes it's like these simple pleasures that really delight us in our homes, and we can't forget about those. And then also, it was really sweet of it was Aaron, right? It was really sweet
Aaron,
of him to share this video with us, because boy, what a very cool project it is. I mean, this is an outdoor shower that he put a lot of thought and care into building, and it's a timber frame structure, and really just a fun video to watch.
Monica, have you found that showering outdoors has changed your life?
Well, I'll tell you, the best one I've ever seen was at the Chinati Foundation in Texas. Donald Judd's amazing art. It's a foundation, so they have lots of different artists there, contemporary art. But he built an outdoor. It's almost like a maze. So you go out, and it's very, very private. But then there's this lovely cast concrete bathtub and shower, and you're just looking up at the sky. It's fantastic.
Yeah.
Andres, you thinking about one for your outdoor patio?
I was actually thinking about it because I might be doing a pool in the near future.
Yeah,
that's the only reason why. Other than that, I'm not that close to the beach or anything.
Yeah, but
else.
Andres, what happens? And I shared this probably on episode 5, but it's been a long time, so we probably have some new listeners. But what happens? I built ours because we were living in a 1-bathroom house, and I needed to remodel the bathroom. And so that's where we were going to shower while I was doing the bathroom remodel. And for the next year, I don't think anyone showered inside. We all just kind of, even long after the bathroom was done, we all just kind of fell in love with going outside and looking at the pine trees while we were showering. And it was the bathroom was long done, and I was getting up early in the morning and going out there in the dark to shower.
I don't know. Your new place, man, is kind of on a exposed location. Maybe you want to put that around back. I don't know. You got plans for a new one?
There's a spot for it.
Perfect.
This comes from Michael. Hello, all at FHB. I've been binging on the podcast for 7 months now. I love the content, the banner, and the interviews. I'd say you've definitely upped my carpentry game in the few months I've been listening. I stumbled across this Instagram feed, and I'm an educator in Philadelphia, which happens to be where I live. I think it would be a great interview. So, Michael Manny of Revive Contracting sent me a link to an Instagram page for Mr. Jarrett, who is a trades education teacher in the Philadelphia School District. And the work he's doing is amazing. You'd be surprised at what these young people are doing, sweating pipes, using power tools. And it looks to me like they're learning far more than the curriculum Mr. Jarrett is teaching in these classes. So, Mr. Jarrett, thank you. I hope you're listening because we'd love to have you on the podcast. I reached out a little bit ago and haven't heard back from him, but I hope you all will remind him to follow up with us so we can have him on the show and ask him about his important work. Did you have any industrial arts or trades educations, Monica, as part of your architecture training or other parts of your academic career?
So the first time I was in architecture school at University of Houston, I decided I really need to learn how to swing a hammer. So I went out, I had this contractor friend, and he took me to this job site in the boonies, and the crew there, he said, well, give her something to do. She's an architecture student. And they literally handed me a fishing pole and told me to go catch them. So anyway, I did catch them lunch, by the way. But but also then I finally decided, well, I'm just going to have to start building things on my own. So I rented this warehouse in Houston. It was amazing, and we just started building stuff, and it was such an education. Just trying to actually build what you think about. And we had 4 different students in there. We built all kinds of stuff. And my favorite thing was to go to the other students after they left, because I was kind of the one that stayed, and start like Jengaing their construction. What could I take out? It's not going to fall down, because I found that they were so overbuilt, but.
Can you tell me why hands-on stuff isn't more a part of architecture training? I'm always surprised that folks have little experience, like actually building the stuff that they're designing.
Yeah, I mean, there are a lot of schools that really do try to do that, with a practicum course that sometimes even lasts more than a year. I know Virginia Tech does a lot of this, even University of Houston, but most architecture schools, in my experience, are very, very design focused. And, I think that's to some extent a disservice, not only to the students, but to the profession, because, there's this idea of architecture with a big A, right? So it's like, if it isn't an architecture with a big A that, somebody's going to write about in a magazine or be world changing, that it's not real architecture. And yet homes are literally the most complex building on the planet, maybe except for nuclear plants or something. But even a nuclear plant has one purpose. They can make rules around it for what goes on in that place, at least while it's operating. But with buildings or homes, everything goes on all the time, and it's always changing. So I think I would like to see architecture firms, instead of focusing on these very large scale kind of commercial, look at me structures, let's look at our existing building stock. What's going on there? There's a lot of fascinating problems and interesting solutions that, we need more of those solutions. Not
And
less.
I think you'd agree that has a huge effect on human health, right?
Oh, yeah. Yeah.
Make people sick.
Well, you can make people sick, and a lot of people are living in a building and they just don't know what to do about it. So they're just accepting the situation. So
we'll get more to that discussion in a little bit. This comes from Josh Zoller, who is an insurance adjuster. Hey, Patrick and team, I listened to the recent episode while writing reports for an insurance company about hail damage to some shingled roofs. I'm an independent adjuster and have done hundreds of hail inspections in the last year. There is science that goes into hail damage assessment of roofing materials. Hague Engineering is a leading firm in the testing and research into damage to all types of roofing materials. Insurance adjusting is a very interesting business. If you have any questions, please let me know. I'm hoping listeners who have insurance adjusting questions or short videos or MP3 audio files or whatever will share those, and we'll get Josh to answer them. One thing that really intrigued me about Josh's email was a link to this Hague Education website, this company that specializes in hail damage investigation equipment. Is the specialty tools used for measuring the thickness of shingles, which is a stand-in for its remaining longevity. There are tools for measuring the diameter of hail impact spots. Fascinating stuff I didn't know existed at all. Have you seen this stuff, Brian?
I hadn't, excuse me, I hadn't seen any of that, and I didn't get to, I just kind of, opened that site and took a quick look at what they do. Didn't have a chance to really dive into it, but I still have, I would love to talk with him more, because I still have questions about, I brought this up before about the fortified standard for homes that's coming out, and I still have questions about the insurance industry driving building standards that I would love to really have some experts to talk with. And it's not that I think that we shouldn't be building to higher standards where it's necessary, but so for example, like with hail damage, if there are things that we can do to homes to make them more resistant to hail, like how. And of course, those things are also going to drive up the cost of homes. So how much hail damage is actually happening in the world, and how do we quantify that against the cost to, the cost that the insurance companies have to pay out to fix hail damage over the course of a year versus the cost of the increase of homes if we made that sort of a standardization for homes, and who actually ends up benefiting? Do homeowners in the home building industry actually homes end up just costing more money so that the insurance companies save more money? Or, is it really in the benefit of homeowners to have to have a house that stands up to hail? I don't doubt that, that the insurance companies can come up with better, stronger ways for us to build, more resilient ways for us to build. I have to ask that. I can't help from asking that question, who benefits from what is going to be additional costs to homes?
Oh, I could go on and on and on, but I'm going to save myself. We're going to deal with this subject in a future issue of Fine Homebuilding because it is of great personal interest to me. I would say society bears the cost, either in the terms of, helping support neighborhoods that are decimated by hurricanes or hail damage or whatever. Folks who would be employed in small businesses locally suddenly are displaced and can't work in the local business to get things on their feet again. And the cost of insurance premiums are borne by all of us, and especially for flood insurance that is subsidized to a great extent by our tax dollars. So what do you think about this, Monica?
Well, I think the word resilience, right? That's kind of what the goal is, that homes and communities are resilient to situations that can happen. And more and more we're seeing, climate change driven extreme weather events happening. And yet our building codes look backwards. It's like we are looking at the past in order to make predictions about the future, but things are changing. And so the insurance company, I think risk drives a lot of things. And certainly, the fortified standard can help to address these risks for those who can afford it. But we also have to look at, what kind of maximum risk is a fortified building really achieving? And if it's the only building in, an
entire community,
a block of buildings that are not. Exactly. Like, what good is that actually doing other than eliminating insurance options for the rest of the people in the neighborhood in a way, right? Or making their premiums higher. So, resiliency sometimes isn't about making things harder, but making them easier to fix. If the cost of fixing it, right? If the damage isn't creating damage to, or risk to life safety or health, then maybe we actually let things break to a certain extent and then fix them properly. So it's a matter of building it in a way that would allow that to begin with. I think there are countries in the world that have that aesthetic and that motivation. For example, Japan, there's a lot of buildings that are literally meant to be reassembled after they fall down.
It's such a big subject, and as Monica suggests, it's only getting bigger because here's an example. In the last, since 2015, there have been 50 storms with $1 billion or more in damages, and every year it's between $8 and $14 billion in hail damage alone. So I mean, the numbers are astronomical. And imagine all the good you could do with those dollars to improve the built environment if you weren't obligated to rebuild things that had blown down unnecessarily. I don't know. It's a complex issue, but I'm going to dive into it more. You know, Monica, in an email exchange ahead of the show, and we were planning our recording session, you mentioned to me that crawl spaces and basements are often problematic from a building science perspective. They have comfort problems. They add to energy bills. It's a constant topic of conversation on the podcast. Do you want to talk about, your experience with bad crawl spaces and basements?
Sure. And I'm in a mixed humid climate zone 4A. So we have lots of basements and lots of crawl spaces. And in the winter, it's very cold and dry. And in the summer, it's warm and moist. And in between, in spring and fall, it's like 75 different seasons because things change all the time. And so, what kind of drives me absolutely bonkers, like I just don't understand. It's one of those things I just don't understand why we do this, is new buildings that you've got, say, a homeowner that says, well, I'm going to finish my basement later, right? So then they don't condition the basement. But the insulation is that means the insulation is either at the underside of the main level floor, or it's like the basement is sort of kind of insulated, like just maybe at the bands and the wood framed walls or something. And so they end up with this, basically it's like, this like orphaned area where you can get a lot of condensation. You can, you have biological growth that might take, might not appear for 2 or 3 years. And then it's like, who's to blame? And then they don't necessarily air seal at the underside of that main level. And so that biological growth and the condensation goes up the walls, like through the stack effect. And so many years down the line, it gets more or less complicated to not just understand what's going on, but what to do about the problem. But with existing homes, there's this idea that vented crawl spaces are the way to go.
Especially in your climate, right? It's very common in Virginia.
Absolutely. Traditional. And they're rainforest machines, literally. I mean, you're literally sometimes creating like a rainforest under there. Biological growth galore, animals that like to come in. I recently was at a site just last week, and they had a decommissioned direct vent furnace, and they left the vents, but the vents themselves were like not sealed. So the vent was like a path for rodents to get down into the crawl space. So there's like all of these things that, oh, well, we don't have to seal it because the air can just flow through, right? And it's like, the air isn't just flowing through, it's flowing in, and then it's condensing at the underside, and then it's, interacting with insulation. Vapor barriers aren't continuous. Then there's the whole termite inspection strip, controversy. Basements don't require it, but crawl spaces do, even if the crawl space is closed. Well, if it's closed, it's kind of like a short basement. So why do you need a termite strip? So anyway, yeah, that stuff keeps us talking.
Yeah, I've never understood that. Why are the codes different for a conditioned crawl space and a basement? They're essentially the same. They're essentially the same thing.
I think it's kind of it's like a legacy understanding of why you need a termite strip to begin with.
Yeah.
So, and the idea is, of course, crawl spaces were traditionally vented and you had wood close-ish to the grade, right? And then termites would get up, into the wood
Yeah.
easily. And but with a basement, I guess the logic was that it was not a vented basement, and so therefore, you didn't have that situation. Um, but the fact is that termites, they just don't like to cross areas that are like smooth or unprotected.
Uh-huh.
Like they like to move around in kind of the dark in the dirt and behind the walls. And so the termite strip was a way to not just inspect but also to avoid this termite making the leap right,
Right.
to the wood, from the grade to the wood. And so I don't know, we see it occasionally. We see companies that are doing crawl space work and they say, oh no, we have to allow this like 3 or 4 inch inspection strip all the way around any kind of enclosed crawl space that they do. But then what that means is they don't even seal the band to the masonry wall, which
The
is like,
biggest source of leakage. Yeah.
okay, but yeah, it's like wearing the shoes, but your shoes are off of your
Yeah.
feet. You're just kind of putting your feet above your shoes. It doesn't work. So
What would you tell folks listening to this show are your things to watch out for, or characteristics of a good crawl space or basement? Can you summarize a couple things that would help folks?
well, I mean, there's this idea that if you condition the basement, you're going to need you're just going to put a lot of additional load on the building. And depending on the climate zone, it's usually not true. It won't put a lot of additional load on the building. And, if you have, for example, your air handler and your duct system in the basement, but the basement is unconditioned, you've got kind of a similar situation as if you put it in an unconditioned attic. Maybe not quite as bad, but maybe more condensation potential even. And so at that point, it's usually pretty easy to just, condition that area minimally. And so for crawl spaces in the building code, there's a requirement of 1 CFM per 50 square feet of crawl space. So if you think of a basement as, say, twice the volume of a crawl space, okay? So then it's like, okay, well, let's provide just 1 CFM per 25 square feet of basement. You're probably going to be fine because then your basement walls are not, or are going to very rarely and for not long durations reach or go below dew point temperature. So you're kind of creating this warmer interior surface situation so that you don't end up with this biological growth. That's what, sometimes that's just, 1 or 2 vents in a trunk line that's already in the basement. That's a good way to do it. The other thing is to make sure that that is actually air sealed and insulated, especially where walls go above grade. And where that's most important is at the bands. And I think I mentioned that, sill plate at the top of the masonry wall, that I see get missed all the time, even in new construction. Don't just put fiberglass insulation in there that's all crumpled up or whatever, because it's not going to stop the air. You've got to think about air first, then insulation. And then, of course, the heating and ventilation, which, by the way, is all one system. Even though you have different subcontractors, that building enclosure and that heating and ventilation and air conditioning system is all one interacting system.
You described it in our email that the building enclosure is part of the HVAC system. And I think that's
Yes,
pretty
absolutely.
punchy. Can you tell folks what you mean by that?
Yeah. So back in the day, right, when we just kind of had this equipment, and there is this, I think there is just in our culture, maybe this idea that technology is going to solve all of our problems, right? And so we can look at an HVAC system and we can say, oh, there's the technology, right? And that technology, we're just going to bring it into this building. It's going to be whatever this building needs. But buildings, a lot of times, if they're new, we can be more intentional. If they're existing, we have these kind of random configurations of insulation or air sealing. So if we don't know what those are, and if we're not intentional about it, then we can be putting the wrong system into that building enclosure. That system isn't going to be optimized for that building enclosure. And at the same time, if we don't control the building enclosure, then we have a chaotic system, which, three-body problem, just I hope you all have been watching that. Anyway, you're creating kind of a three-body problem situation with, moisture, pressure, and heat moving through this building in unpredictable ways all the time, depending on the season. But if you can get control of the building enclosure, you can get control of the heating and cooling system, which means that the heating and cooling system is usually a lot smaller, and you can then get ventilation instead of through these like chaotic penetrations in the building enclosure, like 75 noses in the house, right? Then we can decide, where is the nose for this house? Where's the best air going to come from? And how can we maybe filter that air as it comes in and deliver the appropriate amount of air for that house? So HVAC systems we think of as being engineered, but really we need to be thinking about engineering, or, at least purposefully and intentionally designing how the building enclosure and the HVAC system work together.
There's such a problem with the HVAC industry, and it's once again a regular topic of conversation on this podcast, is training of workers and rules of thumb sizing, poorly sealed ductwork. How do we get around these problems? You mentioned the interface between a building scientist and the other stakeholders in a building project. Does it come to that, or is it more nuanced?
I think the HVAC industry is broken. I am really sad about that. I think it's possibly because of the fact that the people who own, and I'm talking residential mostly, but I've seen situations in commercial as well, by the way, like crazy stuff. That's just nonsense, that they have to pay me a bunch of money to tell them what to do, and then they don't do it. And then they pay me a bunch of money to go in and tell them they didn't do it. I mean, it's nuts. So they don't want to change, I think. And I'm not talking to all of them. I mean, obviously there are companies that are doing an amazing job. But I regularly have to interface in order to adjust, whether it's HVAC sizing, locations of ducts. In existing buildings, basically the rule is you can't make it worse. So it's the Wild West. So HVAC companies just come in, they have very little rules. They don't have to test ductwork. They don't have to, all they have to do is stick in a new machine, and homeowners think that's all they need, right? And you talk about air quality issues, especially when trunk lines or supply lines are made of the fiberglass fiber, built up boxes, as opposed to being metal ductwork, which wasn't supposed to happen to begin with, but it's there. So nobody's really watching or helping homeowners understand what they really need. And it's just kind of terrible. I mean, I think that there can be some regulations around that if municipalities and building planning offices become more aware of it, that maybe there does need to be some oversight there, but it can't just be you have to pull a building permit, right? Because if it's just tied to the code still says just don't make it worse. So it can be as bad as it could possibly be, and you just don't make it worse.
What do you think, Brian?
Well, one of the things I've learned from Monica is that, in helping develop her course and then working on this article on energy audits with her, is that we don't have to leave anything to chance when it comes to heating, cooling, and ventilation. So she for example, I was, this article that I've been editing recently, she talks about how, she makes recommendations for, after she does an energy audit, she makes recommendations for the homeowners, and they're going to, they have an order, but to bring it right to put aside things like human health and durability for a moment and just talk about the subject that we're on, she would recommend enclosure improvements first, and then heating and cooling and ventilation improvements second. And one of the reasons why she puts it in that order, and correct me if I'm wrong, Monica, is because those improvements can be verified. So not only she can do some modeling to predict heating and cooling loads and equipment sizing, but she can also go in with a blower door test and some infrared thermography after the improvements are done, make sure that the improvements have been done well and that the equipment will be right sized and ventilation rates will be appropriate and all that. So there's, what I think is that there's the more we learn, the more equipment that we have, and the more of these professionals pop up around the country, professionals like Monica, the less of this we have to leave to chance. And rules of thumb I hope, will just become a very outdated way for someone to work because we have more, because builders, architects, homeowners will be armed with more information.
Yeah. And then don't get me started about the missing V in HVAC, right? So absolutely, enclosure improvements have to be, even if they're not done before the HVAC, because sometimes you just need one, right? It broke,
Mm-hmm.
right? But you can at least have a game plan, right? For, okay, well, in this case, we can't do the building enclosure first, but we're going to, so that we can have, a right size system or a variable speed system, for example, that can handle the pre and the post. But the other thing I would point out is that, in the implementation phase, so there's the energy audit, the homeowner gets the recommendations. It really should never stop there. What should happen at that point is, because then the homeowner goes and says, oh, I need insulation in my attic. The insulation people come, the HVAC people come, whoever, and they're trying to get the job, right? And they've got their own opinions about how it could be done. And so that's where things fall apart a lot of times. I was just at a house where a homeowner decided to do their own project management, and lots got lost in translation. There were no baffles. There were literally there was like bare dirt in an enclosed crawl space. I mean, it just went on. And it's, thank goodness I had a good relationship with the company that did the installation, so that I could make a friendly call saying, maybe you should go get your eyes on this situation, which they did. I mean, they were out there that Saturday doing it all. But if there hadn't been that intervention with me, the homeowner would have thought it was completed.
And hard to fix, right? Or even knowing what to fix is the obstacle.
Yeah. Yes, exactly. Because she didn't know what she was looking at. She's like, oh, vapor barrier, there it is. Oh, insulation, there it is. Yeah.
I'm guessing you would tell folks that's a poor way to save money, is to manage your own projects if you're not up to doing so, right?
Penny wise and pound foolish, absolutely. Plus, there's tax credits. So, an auditor can tell you about, like, oh, by the way, yeah, this costs you some money, but here there's, money sitting on the table that's going to reduce the cost as well.
We are going to take a listener question now. It's been amazing, Monica. And I said this question to you a little bit ago, and you weighed in on that it was kind of a complex question. And I've done my best to edit it down, but it's still a little long. But bear with me, folks, and we'll see if we can fix Jane's house. Jane writes in, she goes, this year I've purchased Fine Homebuilding All Access membership, and it has been very helpful. Mike Gurton's videos on air sealing and attic were alone worth a subscription price. The podcast is pure gold. In January, we discovered condensation and mildew on the underside of our roof sheathing in the unconditioned attic of our 1937 bungalow in Halifax, Nova Scotia. We were inspecting the attic ahead of a meeting with a roofer to discuss a planned re-roofing job. We were perplexed because this was the first time we've encountered condensation in the 20 years we've owned this house. And we usually do an annual check of our roof and attic. So Jane, I would tell you, Monica, is typical of the folks who listen to this wacky show that are going up into their attics to just make sure things are okay, which I certainly love. Most of the roof sheathing, old tongue and groove, was dry and golden, as it has always been. The only part of condensation was over a small 2008 addition, which is sheathed in plywood, and there was no sign of a leak. The roof is 20 years old and has survived 3 hurricanes. It was replaced in 2003 following Hurricane Juan. The roofers who shingled it in 2003 added a ridge vent. The house has no soffit vents. It has deep overhangs with exposed rafter tails. The first roofer we spoke to suggested to rebuild the chimney to just below the roof deck, blow in additional insulation, even though it would make it difficult, if not impossible, to get into the attic. We are on board with the chimney rebuild, but we don't think making the attic inaccessible sounds like a good plan. The existing insulation is a combination of old and new fiberglass bats. The second roofer suggested certainteed intake vents and wondered if the fixed window in the front gable might be contributing to our condensation problem. We were willing to consider the intake vents and try covering the window, but we thought we should do some research, and that is where Fine Homebuilding came in, and we are glad we checked with you first. We think the uninsulated outside porch is making the front of the attic colder and possibly pulling warm, moist air from the rest of the attic to the front of the house where we found the condensation. We've learned warm moves to cold from reading Fine Homebuilding. Also, the roof over the inside porch faces south and southwest and is undoubtedly the hottest spot in the attic when the sun is out. We wonder whether the heat from the southwest side of the roof is interacting with the colder roof and attic floor over the east side outside porch to produce the condensation, or some combination of the two. The condensation is worse on the side of the exterior porch. We also wonder if removing the front vent might be a contributing factor. There's one further complication, and the old hip roof remains inside the attic in the front and back additions. A hipped roof addition was added to the back of the house in the 1960s. The attic consists of 3 compartments with hatches cut through the hips to the back and connect the 3 compartments. It could be optimistically described as Jules Verne-like. The house feels rather boat-like, with a saloon in the bow, galley and mess midship, and heads and cabins aft. Would venting equalize the temperature throughout the attic and cool the hot spot over the inside porch? Should we insulate over the outside porch? And if so, what is the best way to do so? Presently, there's only a polyethylene vapor barrier over the tongue and groove ceiling on the exterior porch. We placed hygrometers in the back, middle, and front of the attic that confirm the attic is consistently colder and more humid in the front than in the middle or back, except when the sun is out, when it gets consistently hotter and more humid at the front. My husband asserts that what can be measured can be controlled. Fingers crossed. Thanks for reading this. It has taken longer to explain than I anticipated, but the exercise writing it has been clarifying. We'd be grateful for any input or best guess array you have on our situation. Thanks for all you do. The photo of the original house around 1960 is courtesy of the man who built it, an engineer. Sincerely, Jane. You should also know, Monica, we have a lot of engineers listen to the show, and it might be because they're interested in the details that Jane provided about her particular situation. What do you think about her situation?
I think it was interesting just how many parts there are to consider, and her thoroughness in explaining kind of all of the sequential changes and observations. Certainly, I appreciate her recognition that, eureka moment, heat moves to cold, high pressure moves to low pressure, and cold moves to, moisture moves to dry, and which is basically the summation of all that I know. But the question I had was, did they ever do any blower door testing or, leakage testing prior to even the last insulation exercise? And I'm assuming there's no, heating, cooling, or ductwork up there.
I'm going to guess no, that they have not done that work. And you're, I'm guessing, pointing the fact that escaping interior air into the attic space could be condensing on the roof sheathing. Am I scratching at the right itch?
Yes, I think so. And the other thing is that, when we observe, we have to remember when we're observing. And, that I appreciate too that she was like the east side of the roof, right? Because that's always a question. And so, but we're observing during the day when the sun is out. And, but if there's condensation in the attic at the underside of the roof sheathing, barring a leak, which I'm assuming it's not a leak, then it is probably water vapor coming up, and it's freezing somewhere, and then it's melting, right? So it's, a trick with infrared, let's say you have a situation where it's like spring or a house that isn't conditioned at that time, new houses or whatever, is you can do infrareds on the sunny side, or you can do, because literally that radiant energy is going to produce a lot of heat that might not transfer directly into the air where you're measuring the air, but certainly to the surface. And so that's typically when you see condensation, is when that sun comes out in the morning and then it warms that surface and then that water condenses. And also, where is this water coming from? I think she said the um, the bedrooms and bathrooms are aft, right? So and the galley is forward or in the middle. But anyway, the moisture that gets generated, I suspect, at the rear of the house is making its way up into the house and then getting pulled forward at nighttime, freezing on the coldest spot, which is above the porch, and then condensing when the sun comes out. That's my working hypothesis.
Is roof venting a red herring as it often is in these conversations?
Yeah, and in the code it says that you have to have a equivalent net vented area, I think is what it's called. And so, which basically means that for roof venting to work properly according to code, your eave, the total net holes in the eaves needs to equal the total net holes in your ridge vent or wherever. And if you have gable venting, that could be different too. But but whoever measures that, I mean,
Right.
like I measured it one time and it was just like, this is kind of nonsense because nobody ever does it. So as long as you are harnessing that stack effect, you should be fine. But in this case, I think the stack effect is working against them. And also the other thing to remember is, you know, heat goes to cold. Heat doesn't necessarily go up. He can go sideways and move in circles and go down or do
Yeah.
whatever, as long as, you know, it's colder, you know, drier and less pressure at a certain area. So, you know, I kind of tossed around in my head, like, well, would, you know, continuing the insulation and air sealing over the porch roof help? No, because the air is coming up and through. You know, does it have maybe something to do with the window? And I think I read new window. So was, you know, somehow and I saw there was like this little like a header trim that projects out over the window a little bit. It was real cute, but you know, is the air coming up through there, maybe from the ocean? But you know, even though the ocean and the moisture is there in the winter, it's so cold that the air isn't holding a lot of moisture. So,
And that leads you to believe it's
I'm
coming from the interior, right? Yeah.
yeah.
What about, are there just times in the year when certain parts of the roof, north facing jumps to mind, could be a condensing surface just because it is the coldest thing owing to night sky radiation? Or is that also a fallacy?
Well, that's where it would most freeze first, right? I mean, you know, if you had a situation where you're producing a lot of interior moisture, it could freeze on any side of the roof, but it's always going to melt first where the roof gets warmest first. And that's typically going to be on the sunny side.
Well, you know, I think Jane got a good deal with regard to her building science consult on our podcast. What do you all think?
I don't know. Do y'all have any other theories? Because, you know, I'm not always right about these things.
I think you just
Well,
got to
you're-
monitor it and see if it's a problem, you know? And I believe
Yeah.
I've gone up to my attic in certain times of the year, especially in the spring, when it's wet on the sheathing. And, you know, it's hot up there, so it dries out. I do have a ridge vent and soffit's venting, but we know that that's not always reliable. But I would monitor it and see if it's a problem before you do anything super rash. I think an energy audit blower door test is a good first step for a number of reasons outside of the condensation issue.
Yeah, absolutely. And, you know, the other thing is, you know, did they just notice this condensation? Or, you know, has this already been going on like all the time and then, you know, they just now noticed it, right? Because this might just happen like when the weather does this one weird thing.
That's what I would want to
So-
know before I spent tens of thousands of dollars to fix a
Agreed.
problem that
Yeah.
doesn't really exist.
Yep. Things can get wet. They just can't stay wet.
Well, I hope you all will tune into Monica's Fine Homebuilding e-learning module on indoor air quality. And if you do, be sure to use our special discount from the podcast at air quality, all caps 40. And I believe you'll save 40% on the price of the class, which I think is pretty awesome. And it sounds like there's going to be tons to learn. I can't wait to tune in myself.
Thank you. I can't wait to see the questions that come up.
Do you have any words of wisdom, Monica, before we close up the podcast for this episode?
Yes, build it tight, ventilate right. Both parts of the equation are equally important.
That sounds like a mic drop to me. It's been a pleasure talking to you, Monica. Thank you so much for being on the podcast. It's been a pleasure.
It's been my pleasure. Thank you so much. Great to see you all.
Well, unfortunately, that's all the time we have for today. Thanks to Monica, Brian, and Andres for joining me, and thanks to all of you for listening. Please remember to send us your comments, questions, and suggestions to FHBpodcast at finehomebuilding.com. And please like, comment, or review us however you're listening. It helps other folks find the podcast. Stay safe, everybody. Keep craft alive. Build tight. Ventilate right.